He is the consultant of Abhirami Hospital, and he is the HOD of Department of Diabetology in Coimbatore Medical College. He did his MD General Medicine in Coimbatore and Diabetology in Madras Medical College. So, go ahead, sir.
Thank you, dear chairpersons. Very good morning. So it's a great privilege to be here in this TRAC 2025 Coimbatore, and it's still a greater privilege because I am given a topic that is extremely innovative. Now, I have two statements to make. One, they always give me the first talk after a gala dinner. And number two, they always give me a talk that is little very difficult to search for. So this time, this is intergenerational transfer of metabolic memory. So before starting this, I would like to give a small tidbit of medicine and praise ourselves. We all know that only half of the people lived till the age of 30 when we were cavemen. In 1840s to 1900s also, the half-life of men or mankind was only 35. But only after the advent of this modern medicine, now not even a single baby is allowed to die until he becomes an elderly. So this is because of the major advancement of modern medicine, not exactly like what others now promote. Cavemen ate organic, breathed organic, drank only pure water. But in today's life, we have everything polluted and we still live on. So let us take the credit to the medical fraternity that we are doing a wonderful job in saving the mankind in spite of all the disadvantages. So what could be the reason? So there has to be something that has been passing on from one generation to another. So I am going to promote the idea, don't feel guilty if you are a diabetic today, if you are overeating. Pass the blame on your grandparents. So this is the concept of intergenerational transfer of metabolic memory. So my agenda is like definition, mechanisms, implication, and prevention. So basically there are three concepts here. One is the metabolic memory that we have, all of us know. It is like the legacy effect. A person with any metabolic abnormality, when treated early on, and if he loses follow-up, the early good treatment still carries on with a better prognosis when compared to a person who has never been treated at all. And the corollary is, the patient has been not treated early on and it still progresses, that the patient will have a poor prognosis later on when compared to a person who has been treated regularly. So next comes the intergenerational memory. This is any metabolic abnormality in a parent poses a high risk of the same metabolic or another metabolic disorder in the offspring. So this is intergenerational memory. And the third one is the transgenerational memory. Here, metabolic abnormality or any poor metabolic situation or abnormal metabolic situation in the grandparents can be passed on to the grandsons and so on. So how does this happen? And this is what we are supposed to see. And do we have any evidences for this? There have been so many studies that tell us that the metabolic traits and risks can pass on from parents to sibling without changes to the underlying DNA sequence. So how can this happen? And what are the evidences behind this? So one, we all know that the Barker's hypothesis, often spoken on, it tells us that when the mother is undernourished, the offspring can have a high risk for metabolic abnormality like obesity or diabetes mellitus, basically because of the thrifty gene hypothesis. Because when the fetus is exposed to low nutrition when in womb, it develops the capability to store the energy, but after a while when the fetus becomes an adult, is exposed to excess nutrition or even normal nutrition, they are not able to tackle the overnutrition by burning excess fuel, but it tries to still store on, leading to the malnourishment. So this is basically all the first 4 or 5 studies that I have posted are basically on the mothers. And further, these are those Barker's hypothesis and thrifty gene studies were basically hypothesis, and those were like further substantiated with a few studies like the Dutch hunger winter study. Here in Dutch hunger winter study, it was a study that was undertaken in the in Netherlands, where grandparents who were it's one of the famous influential studies. This was done in the famine periods of the Dutch between 1944 and 1945. The individuals whose mothers were exposed to famine during the early stages of pregnancy had a higher risk of developing obesity, cardiovascular disease, abnormal glucose metabolism in adulthood, and more remarkably, their children, that is the grandparents, who were not directly exposed to the famine in any way, also showed risk of increased risk of obesity and altered metabolic profile. And this was also substantiated by an overcalic study. This was also done in the Scandinavian population, the same kind of study. And then the Pima Indian population. This is little interesting because we all know that they are predisposed to high rates of type 2 diabetes mellitus. The researchers observed that the offspring of the women with diabetes during pregnancy had a significantly higher risk of developing diabetes themselves. But the interesting point to note here is the same mother, when she delivered a child before she became a diabetic, had that offspring to be healthy. But the child that she born after she became diabetic had a higher risk of diabetes mellitus. So here we have to note that any metabolic abnormality during the period or the process of conception can be highly influential. If it was basically a genetic problem, this is not the possibility. A baby born to the mother before she developing diabetes or after she developing diabetes could have had the same risk of developing diabetes, but it is entirely different. Not only this, also there are problems with the fathers, like the studies on the father. There are basically 2 studies that were done on the animal models, wherein it was seen that the researchers bred the male mice with healthy food and the fat and high fat diet, and they were mated with non-obese females, and they analyzed the metabolic health of the offspring, and it was found that consistently found that the offspring of a high fat diet fed fathers had an increased risk of diabetes and obesity. So these are also very clear evidences that paternal influence on the baby is also as an important factor during conception. And this is a human study. This is an ongoing study wherein the research focuses on the molecular changes in sperm from the obese patients before and after intervention like bariatric surgery. So they found that the obese men have a different DNA methylation pattern. So I'll come to the DNA methylation later on, and non-coding RNA profiles in their sperm compared to the lean men. Furthermore,